All right, what do we got here? We got A255. It's actually 3.4. I need to change this document. I'm reusing some of my old stuff instead of what's in your book, but it lines up perfectly with the Division Algebra 2. We're supposed to do some long division. And why not do the first one? So I'm going to divide x squared plus x minus 17 by x minus 4. And I'm going to go back and think about 5th grade. I'm going to put x minus 4 on the outside. And inside, I'm going to put x squared plus x minus 17. I don't think this is going to be a factor, but it could be. We'll find out. Anyways, to become an x squared, I need an x. And then I kind of think about using the distributive property. I distribute x squared minus 4x. Then I go back again to 5th grade and I think about that old algorithm. I subtract and I write before I subtract. X squared minus x squared is nothing. X minus a negative 4x is 5x. And I carry down, just like I used to when I was a kid. Now I want this x to become a 5x. X enters 5x, a positive 5x, a positive 5 times. And again, I invoke the distributive property. 5 times x is 5x, 5 times a negative 4 is negative 20. And I wrap before I subtract. And a negative 17, not minus 20, but plus 20, because I'm taking away a negative, is 3. And I'm done. There is no way that x enters 3 unless you use negative exponents. So I have x plus 3 plus the remainder, which is 3 pieces of x minus 4. Now down here on these questions I've got, what is f of 4? F of 4 is 3. You see this 3 here? Had I actually gone off the side and found f of 4 by plugging in a 4, I would have gotten 3. This is 16 plus 4 minus 17, 20 minus 17. It's 3. Trying to establish the relationship between the remainder of division and lost my train of thought here. I'm tired. And plugging in a number. It's actually called remainder theorem. All right. Was x minus 4 a factor? Why? No. The remainder was not 0. Plain and simple. Remainder wasn't 0. All right. What do we got here? We got 3. It's underlined too, which means at some point in time I thought this was worth recording. If f of x is 4x squared plus 5x minus 4 and g of x is x squared minus 3x minus 2, find f of x divided by g of x. So literally going to do this exactly what they tell us. We're going to do long division. The outside is going to be x squared minus 3x minus 2. By the way, you probably need to be writing small. I know that's an issue for some of y'all. I am going to insert placeholders. There's a jump between x to the 4th and 5x. And that was a 4th. I need a 0x cubed, and you don't have to do this, but it helps, plus a 0x squared plus a 5x minus a 4. When I'm doing either long or synthetic division, I want my exponents to decrease by 1, all the way down. All right, how do I turn, or how many times does x squared enter 4x to the 4th? The answer to that question is 4x squared. And you'll notice I do little things like put corresponding parts usually over where they are. These are x squareds. That's entirely optional. You can put them up front, put them in the back, doesn't matter. But 4x squared times x squared is 4x to the 4th. 4x squared times a negative 3x is minus 12x cubed. And 4x squared times negative 2 is minus 8x squared. And I wrap before I subtract. But y'all ain't going to listen to me. That cancels. The leading thing always does. 0 take away negative 12 is 12. 0 take away negative 8 is 8. And we're going to bring this 5x down. All right, how many times does x squared enter 12x cubed? The answer is 12x times. The number's starting a little bigger. 12x times x is 12x cubed. 12x times negative 3 is minus 36x squared. 12x times 2 is minus 24x. And again, I wrap before I subtract. Those cancel. 8x squared minus a negative 36x squared is 44x squared. 5 minus a negative 24 is plus 29x. And I drop. This time, x squared enters 44x squared a positive 44 times, and I'll get 44x squared. What do we have there? Minus 132x. Seems legit. Minus 88. And again, I'm going to wrap and subtract. That was 132. Got kind of small there, didn't it? All right, the x squareds cancel. 29 minus 132x is negative 103. Seems off. 44 times 3. Oh, and it's minus a negative. I'm not adding. 120, 132. Brain fart. It should be 161x. And a negative 4 plus 88 is going to be plus 84. And x squared does not enter 161x. So I'm done. So plus 161x plus 84 pieces of that. And we're done with that one. Let's look at 5. Why not? This one won't take near as long, and this might actually be a factor. We'll find out. Tomorrow you get to learn about synthetic division, which will just blow some kids' minds. And it's so easy. But the issue is we come into class and you give me about 3% of your attention. Like you got to come into class and you've got to be paying attention. You've got to learn how to figure that out, how to just pay attention to people. Even when you're not interested, you've got to figure that out. Anyways, I'm going to turn an x into a 2x squared by multiplying by 2x. That'll be 2x squared minus 10x. I'm going to wrap before I subtract. A negative 7 minus a negative 10 is a positive 3x. I'm going to bring down that 10. I'm going to multiply by 3 because I want x to become 3x. And it was not a factor now, was it? If I wrap before I subtract, I'll get 25. So plus 25 pieces of x minus 5. What is f of 5? It's 25. It is 25. If I plugged a 5 into that equation, I'd get 25. And looking at it real quick, that's exactly what you get. Was x minus 5 a factor? Why? No. The remainder was not 0. Plain and simple. You're a factor if you have a remainder of 0. It's called remainder theorem. I'm going to pause this real quick, take myself a little break, and then I'll be right back. You'll never know because it'll be instantaneous on your side. All right, we're supposed to use long division and determine if x squared minus 1 is a factor of something. And if yes, what is the other factor? If I remember right, it's supposed to be. But I made this sheet several years ago, so couldn't tell you. It's not going to be that bad. It's going to have 2 lines. X squared enters x cubed x times. Invoke your distributive property. X cubed looks like minus x. And again, we wrap before we subtract. That's gone. There's 4x squared minus nothing, which is still 4x squared. Negative x minus negative x is nothing, so plus 0x. And then we bring down the negative 4. Now I'm going to multiply x squared by 4 to become 4x squared, so plus 4. And I'll get 4x squared minus 4. And I'll wrap before I subtract. Bam, 0. So it turns out this tells me x squared minus 1 is a factor. And the other factor is x plus 4. So it turns out that this thing actually factors as x squared minus 1 times x plus 4. And it turns out it factors again. It factors as x plus 1 times x minus 1 times x plus 4. That's called factoring completely. All right. On number 8, we're given a 0, and we're supposed to factor it completely. So if you'll go back and look at your notes, if f of a is 0, x minus a is a factor. Somewhere in your notes that's written down. Should be, or you didn't take notes. So if f of 10 is 0, the factor is x minus 10. No, we're just going to do some synthetic division, or long division, sorry. And this one's going to take a minute. I'm going to have to multiply by 4x squared, become 4x cubed. 4x cubed minus, looks like 40 x to the second. Wrap and subtract. That'll give me 10x to the second. Bring it on down. Minus 106x. I'm going to have to multiply by 10 to become 10x squared. Sorry, 10x. 10x squared minus 100x. Right before I subtract, I'll have a negative 6x. Bring down the 60. And I'm going to multiply by a negative 6. So that'll give me negative 6x plus 60. And again, I'm subtracting, and I get my 0. So what did I learn? I learned that one of my factors was x minus 10. And here's my other factor, 4x squared plus 10x minus 6. And I'm tasked with factoring it completely, so I'm going to focus all my attention on this trinomial. I notice that that trinomial has all even numbers. I'm going to pull a 2. That makes the numbers smaller. I'm going to move this 2 out front because I can. With multiplication, order doesn't matter. You can put something anywhere and you're still going to get the same product as long as it's through multiplication. To create a 2x squared, it takes a 2x and an x. Factors of 3 are going to be a 3 and a 1, presumably in that order. We'd need to add 6 and take away 1 to add to 5. That is the complete factorization. Give me a minute, I'm recording. All right, the last one I'm going to do is part B for number 11. Formula area for a certain polygon is, for surface area, is A equals 4xy plus 2x squared. This is a box, by the way, it's a prism. Anyways, you're supposed to solve for x. So, first commandment of math is if you can pull it, pull it. I can pull an x from 4xy. Well, fudge, I can't do it there, can I? May not be that easy. Dead end, sorry. Solve that one for x. Now, how are you guys going to do that? With this, what you know? Actually, I think I'll come back to this one. That's a tough little problem. And I've only got a couple of minutes of lunch left. So give me a second.